and some other boring headers. Wow. That's a boring. That's quite the cookie. Okay. So let's do something else. Let's do a pipelined Git. So that was really easy to do a single request. But Mordor supports lots more than that. So the request objects support pipelining, which basically means that pipelining is when you send multiple requests without waiting for the response. And so far, it's an HTTP library. Sure, it looks great using IO Manager, but big deal. There's other HTTP libraries. Why would I want to use this? So let's do pipelining. Doing multiple requests on the same connection at the same time is either very, very difficult with other libraries based on some callback mechanism, or most of them just don't support it at all. You have to wait for the previous request to complete before the next one. So let's do this. Void do request on broker pointer broker. So I'm just going to move the meat of it into a separate function. And then I'm going to just log that I did it. Actually, I don't even need to log anything because I'll just look at the log output, which has the request headers. And I do need to request finish is a helper method that says read the rest of the response, just get rid of it so that the next request can happen. And then I'm going to do a IOManager.schedule boost bind address of do request, passing it the broker. 1, 2, 3, 4, 5. And I don't even need that. Okay. Where's my make? Get.log. Let's clean up our log. We'll run it. Should get no output. Then we look at our log. You see 1, 2, 3, 4, 5 requests happen, and wow, the screen is scrolling very slow. There we go. And multiple responses. Yep. So I can see right here, it has the context. This is the 5th request that got its response. And it did all the requests at the same time and got the responses. So, a web browser would want to use pipelining to get all the images for a web page. After it's got the web page, then it can just schedule a bunch of requests. They'll all happen in parallel, and it works great because of fibers. So each request ran in its own fiber here. When I scheduled that function, each one of those became a new fiber, which used the same request object, or broker object, which is fiber safe. It's safe to use from any fibers. Theoretically, it could be multiple threads. So let's do that just for fun. Let's use 4 threads. And so we can see right here, let's see. Oh, thread. Did we even get to the other threads? Nope, must not have been enough work to actually get to a different thread. This is the thread and this is the fiber. So we can actually look. What is it? So our fiber context here, the first request was running on this fiber, 100 D100 D00 F20 was the one that connected. Then the second request was running on a different fiber. And then let's go look at the first response right here is running on the same fiber. But the second response was a different fiber. Different fiber. And you can do other things here. So let's be mean to Yahoo servers. Headers.requestLine.method equals put. Okay, we're going to try to put to their home page. So after this request returns, the headers have been written, but the body has not been written yet. So you don't have to have your body all ready and send it all off to the function. You're responsible for writing the body. You get to control that data transfer, which in our case, we're going to write random data. Transfer stream, request stream. I should probably put a try catch here just in case Yahoo decides to hang up on us. We're transferring from the random stream to the request stream. Let's transfer, sure, 65,536. So HTTP, you have, on a request that has a body, you have to give it a length somehow, whether that be just setting the content length, or I'm going to do general.transfer encoding. I'm going to tell it to use chunked. And by simply setting the header, the HTTP client here knows to put a HTTP chunked stream on it. So when we write to the request stream, it will automatically add the chunked headers, and then we need to tell it to EOF. So you have to close the stream.